As you know, many of you know, Allison's been kind of shadowing the task force. We've essentially, I'm just, since we've got a broader audience here, let me just make a couple quick comments. The task force, the core of the task force originally was NOAA and ASCE. We've expanded that to try to bring in, a broader perspective on how federal agencies could work with the civil engineering community. That's led to Terry's involvement. John Ingargiola from FEMA is involved. We're exploring adding some DOI perspective. So really the distinction between who's a formal committee member we've kind of loosened that up. It really should be a collection of people that feel like they have something relevant to contribute to the discussion. We are very much focused on ASCE standards and manuals of practice because those are the formal articulation of ASCE's view on how climate resilience should be implemented at the project scale. And so that kind of provides us a lens to make sure that we maintain a fairly consistent focus. There are so many different potential applications of climate information in civil engineering practice. It would be impractical for us to try to cover them all. So the way we've set a priority is if it is an ASCE standard or manual of practice that's either ongoing, being updated, or considered in the future, like a new standard or a new manual of practice, then that falls under the kind of the rubric of the task force. And that's how we kind of try to maintain some focus. Allison has been with us now for a few months. I think, it's great to hear from her and NASA about how they might be able to contribute to this. So with that, Allison, I'm just going to shut up and turn it over to you.
Thanks, Dan. So for those of you listening on the recording, please feel free to reach out to me directly if you've got any questions. For those of you here today, thanks for taking the time to listen about some of the ways that NASA Earth Science can potentially play a role in the really important work that you all are doing. I think that like a lot of the federal agencies, we're working through where and how we can provide this support. And so what I've done here today is developed a presentation that is really through the lens of where I see potential connections to the ASCE Committee on Adaptation to a Changing Climate. And these connections could potentially be through data products, research, analysis, subject matter expert consultation, and applications as well. So this is a bit of through that lens, but there's a lot more that NASA has to offer. Next slide, please. Just for the broad context, for over 60 years, NASA has used the vantage point of space to study Earth as a system, our ocean, our air, our water, and our land in an interacting and complex landscape, and really looked at the Earth through a systems level. And to develop, and we do this in order to develop an understanding of how and why the Earth system works, how it's changing, and what that means for Earth itself. And in the next slide, the primary way that we do this is through our observational capacities on satellites. We have a lot of satellites that are in development, are already up flying, will be flying in the future, collecting an incredible number of observations. And this is only a subset of the fleet of satellites that exist observing our Earth. NASA works closely with other federal agencies, most notably on this call, NOAA, as well as international agencies to make these observations. And we also have plans for our next generation of satellites on the next slide called the Earth System Observatory that is looking to make even more measurements and more in-depth measurements to give us even more understanding of our Earth and how it's changing. And on the next slide, I'll emphasize that while observations are, at the core of what we do, we really do a full breadth spanning technology, flight, that's our nickname for how we launch things into space, satellite development, research and analysis with those observations, data and computing to enable research and also to enable the community to do their research and following open science practices, And then finally into applications. And what we mean by applications here is really the use of NASA Earth science knowledge writ large to inform decisions in the public sector and in the private sector, and really focusing on that end user decision support. So we really have a breadth of activities in this general realm. And what I'm going to do here is focusing mostly on the data and modeling and applications, because that's where I think we can bring some things together potentially to support this work with ASCE, though there might be other possibilities as well. And I more than welcome any conversations with any of you here or virtually to facilitate that conversation. So on the next slide, getting started with NASA data. NASA is very committed to open science, and that means not only making our data freely and publicly available, but also taking additional steps for our open source science initiative, which is focused on making data transparent and accessible and inclusive, and also focusing on reproducible science. And that means not just making the data and the derived products available, but also supporting their use in the cloud environments and broadening their use to a variety of end user communities. There's a lot of efforts to sort of lower barriers to access. There's a lot of efforts to reach communities who may find our information useful, but don't necessarily have the awareness to do that. We have trainings on how to use satellite data and how to use other observational and data modeling products from NASA. And then we also are having a push to make some of our data sets available in GIS formats, which is really important for a lot of applications users where they don't have, their expertise is not in the remote sensing. Even pulling data from the website and processing it can be a challenge. And so making it available in GIS formats can be really helpful. Earth data is our gateway to NASA Earth observation data. And we also have a variety of data pathfinders that can help walk you through various activities. You can get there through this QR code, or if you just Google NASA Earth Science data pathfinders, you'll probably find, or data pathfinders, I should say, you'll probably get this information as well. And so on the next slide, we bring these observations together in numerous ways. And one of the key ways that we do this is through models and model observation synthesis, because really that's where we help, all of this work is where we help develop the process understanding of how and why Earth works the way that it does. And one of these key activities is MERA. And I'm going to talk about MERA specifically because of its connection to things later in my talk. MERA stands for, NASA's really good at acronyms, Modern Era Retrospective Analysis for Research and Applications, and we're on version 2. And so what this is a retrospective analysis of historical meteorological observations that provides global continuous representation of weather and climate. So it's not observations, it includes observations, and observations, model, and data assimilation are the key parts of it. The observations provide the reality, but observations can be irregular and irregularly available in space and time, and there are lots of different kinds of observations. The models provide sort of this complete and consistent background to estimate what's been happening, and that's the retrospective part, and then also can be used in certain forecast modes. And the data assimilation considers the uncertainty of the model and bringing in the observations and merging that for forecasting and helping set initial conditions. This MERA product is quite coarse in spatial resolution compared to many of the things that people have been talking about on this call, but does have a high temporal resolution. In the future, we have a reanalysis for the 21st century coming that will include some ensemble forecast spreads that may provide some forms of uncertainty estimates. So again, MERA is not observations, it's sort of that model observation synthesis. Another key sort of modeling and high-end computing product that we have are climate projections. One key one is the global downscaled climate projections for CMIP-6. This is a globally downscaled data set produced by our NASA Earth Exchange team at Ames in collaboration with Bridget Thrasher. It's at a coarse spatial resolution, but relatively speaking, but is global in extent, has a daily frequency, which is common amongst many downscale data sets, and also has a variety of variables associated with it. So Max and precipitation are common ones that you'll find in a lot of downscale data sets, but they've also done it for relative humidity, wind speed, downwelling long and shortwave radiation. And they're also working on developing a variety of indices and calculating some variables associated with this, because the downscale data itself, most people, don't just want the map of temperature and precipitation. They're interested in specific variables like number of days above 95 degrees Fahrenheit and variables like that. And so we're looking to make those available as well, and also to make this available in GIS formats. Another one coming up in the future, sorry, just go back one slide, please, is a downscale climate projection at high spatial resolution for CONUS. And so that would also have a daily temporal resolution, not as many variables, but the spatial resolution would be much greater or much more, a finer spatial resolution. And this is comparable to a product we produced many years ago, I think for CMIP 3, and this would be focused on CMIP 6. So now for the next slide, moving into, sorry, just looking at my notes here, moving into applications. This is the program where I sit, and where we look to bring observations, models, research, and analysis together to support specific decisions. And so the mission is to enable people and organizations to apply insight from earth science to benefit the economy, health, quality of life, and environment. We have 3 lines of business: mission engagement, which is sort of about maximizing the capabilities of our satellite missions to support applications; capacity building, and for those of you who would like to learn a little bit about remote sensing, if you're not familiar with it, you can Google NASA ARSET, and you can find some courses on that. And then we also sort of have our thematic applications programs, which you see here on the right. If we go to the next slide, climate resilience, and it also, in a sense, energy applications is where I sit. And this is a relatively new program within NASA on the climate side. And the goal there is really to think about what is the opportunity space for NASA to leverage NASA Earth science information, which includes observations, models, and everything, really to supporting decisions related to climate and resilience. So thinking more about like strategic decisions of the future, things like building standards. And that's kind of one of the reasons I'm here today. Also, our energy program, and Paul Stackhouse, my colleague who introduced himself earlier, is the expert on this. This is the Power Project has been his brainchild. Is one where we have the agency has experience working with an extension of the civil engineering community, perhaps, informing building design standards. So on the next slide, I'll go into the Power program. And so POWER, yes, another NASA acronym, is the prediction of worldwide energy resources. And it aims to improve the capability for integrating environmental data from satellites, from Earth observations, regarding surface solar irradiance and other related parameters into decision-making in 3 key areas. One is renewable energy development, like siting for solar. The second is building energy efficiency and sustainability. That's the one I'll be going into a bit more depth. And then the third is in agroclimatology applications. And the commonality here is actually the underlying data sets and the processing of those data sets that supports these 3 somewhat related. The agriculture is a bit different, but distinct areas. So what I want to emphasize here is that POWER utilizes both satellite observations as well as the MERA-2 reanalysis that I pointed to earlier to provide key variables of interest to the energy and building energy efficiency community. And they do so in a way that helps assess the data quality and provides information on uncertainty, and does so through the lens of specific application areas. And so, is data good or bad? It's fit for purpose, and they help really make that data more useful and usable so that it can get used by these various communities. The second is that they help process these really large data sets and can be quite unwieldy, and help really hone it down to the key information that users need. They make it available through web services in a variety of formats. And then they also work with user communities to understand what their needs are. On the next slide, we really go into the relationship with the American Society for Heating, Refrigerating, and Air Conditioning Engineers, or ASHRAE, and how the POWER program has really worked with them to leverage NASA data to inform building design standards related to energy use. MERA has been a really powerful data set or model output to provide spatially consistent information about climatic zones. So ASHRAE is concerned about a lot of things, and they have climatic data for building design standards. And so they've incorporated MERA data, which has proved to be an improvement over some of their work in focusing on surface observations and the global availability of it. And what they've done with this information is helped understand where map building climate zones, which informs which HVAC systems and other kinds of energy systems that are involved with buildings. It's also used to help understand building performance if your building is under or overperforming, and then also to help look at these thermal climate zones. And so it's really a case where we've had this collaboration to inform standards with an ASCE-like organization. And that's why I'm really talking about it today. One of the things that you may wonder at this point is, but what does this mean for future climate, right? And that's really what we're thinking about, is what is the climate of the future in this conversation, in this task force here? What will the climate of the future be? And how do we have standards that reflect that climate rather than the historical changes? And so where this all comes together is actually on the next slide, through a NASA effort that's closely related to this ASCE work called CASI, or the Climate Adaptation Science Investigators version 2. We like to throw out lots of acronyms for you all. And what this is really an effort to apply NASA science to our facilities planning. And so planning for our facilities and centers around the country, including some iconic ones like Kennedy Space Center and Johnson Space Center in Houston. And really, this has been kind of a mini focus of what the kinds of things that I think that ASCE is looking for. And so they're focusing on a lot of topical areas, but they are basically leveraging the work of GDDP, that global daily downscaled product that I mentioned earlier, and using that to understand the climatic conditions of the future, and honing that knowledge around the specifics of various NASA centers and facilities, and using that to work with our Office of Strategic Infrastructure to incorporate that thinking into their master planning, into their resiliency planning, and into other activities that they're doing. And then also thinking about how this works with some NASA requirements for facility and design standards. And specifically on the next and actually last slide, they're looking at key energy variables. So they've been within the connection back to power. They've been looking at system sustainability for operations and maintenance and planning under these climate change scenarios. And so they have been looking at, like, if you look at on the bottom right, that's information for NASA Langley, and the picture of NASA Langley is above it. And what you see here are cooling degree days. And so again, it's processing that information that we have in ways that are particularly pertinent to planning and infrastructure. And you can see here how under various climate change scenarios, and then also where we have observations and historical models to understand how these cooling degree days will vary under various climate change scenarios, and then using that to think about how you inform building design. So on the bottom left, what you see here is actually the low, medium, and high scenarios that were looked at, and the projections out to the future. And for NASA Langley, which is in Hamptons Road, Virginia, you can see how the building climate zone will change in the future under different scenarios. And that's the kind of way in thinking about how do you prepare for the future. So just to wrap up here, I'll say, I think that NASA has a lot to offer. The very specific entree points are things that we're working through. I'm happy to discuss further. But this is a topic that I think is really important, and we're really interested to be here. I want to thank my colleague Paul, who has done a lot of the power and COSI work that you saw me talk about, and is really going to be the expert that I'll point you to for very specific questions. And I see that he's been posting things in the chat. So I hope this has been helpful, and I'm happy to take any questions if we've got time.
Thank you, Allison. I think we've got time for a few questions. I think this definitely merits. So who wants to start?
Paul, I think there was some echo. Mine being muted unless you're talking.
Then I have a question.
Hang on, let's see if we can get this echo sorted out.
I think it's on Paul.
Are you sure? Because I wasn't talking.
I know it's feedback because you don't have a headset on.
Okay.
Thank you.
Okay, Bilal, go ahead.
First of all, thank you so much, Allison. This is so informative, and I very much appreciate it. My question is about, I know you are trying to reach out to researchers and users and communities outside NASA. Can you give me like an understanding, maybe enhance my understanding to what extent that is happening, and what are the plans in that regard, and how it can be done?
I'll answer that in two ways. The first is, very generally speaking, our applications program is part of our kind of Earth Science to Action framework. And the entire focus of that program, tens getting closer to $100 million, is focused on bringing NASA Earth science information to decision support communities. We have that in a number of thematic areas, and in each of those thematic areas, they've developed partnerships and connections to people outside of the federal government, or even other federal agencies at times as well, to work on that closely. So for example, I worked in a project many years ago in kind of more in a biodiversity and ecological conservation kind of setting, where they had collaborations with the Fish and Wildlife Service, where they had collaborations with the Nature Conservancy, and sort of people who are making those kind of land conservation decisions on the ground or in the water. And so that's the kind of work that our applications program does. We have historically done that through grant solicitation. So we have a solicitation on a given topic that has an applied sciences focus. And so we fund activities that way. We also sort of fund programs and fund specific directed activities. And so Power is a bit of a different kind of example of where they have developed a web service to support the various communities that has the data expertise and the kind of the three, what I talked about earlier. And they've developed collaborations with ASHRAE and with other organizations. I can let Paul speak to that more specifically, but does that help give you some color for the specific ways that we work? And good, okay. Paul, did you want to add anything about maybe some of the specific end users that you've worked with, or partnerships that in turn work with end users?
Sure. First, is my echo gone? I put my earpods. Okay, great. Well, thank you, and thank you, Allison. Yeah, we've worked with ASHRAE for many years, and I don't know how familiar you are, but they seem to have a similar structure. They have a climate committee within ASHRAE. Now so working with them has been it's been very good, because they have some rules, and some of those rules are that they have to use surface measurements, they have to contract an ASHRAE contractor to prepare data sets. So those rules, they can't just go to a website and take our data. But what we did is, by working with the committee, was showed them that an atmospheric reanalysis had enough accuracy to be used to assess the various different statistics of temperature, moisture, even precipitation and winds. And of course, we do solar irradiance from satellite estimates on a global basis, long term. And those are actually being used. We have a satellite mission called Ceres Clouds and Earth Radiant Energy System. Those are currently, if you order ASHRAE's weather data, you can actually, it'll actually go in there, and if you ask for solar radiance, that'll essentially be Ceres at that location. So we've been able to work with them, show the usefulness of the data for the statistics that they needed. So, and when we showed them those maps, they'd only used surface measurements and to derive similar maps in the past, and never really saw it on a global basis, and never saw things where we actually showed them an integration through time. So they could see the changes in the zones over the last almost 40 years now. So that was very eye-opening, and it led to them being open and using atmospheric rate analysis. So they had to get their own contractor and get the data, but that's been the kind of synergy, symbiotic relationship we've had with them. We've also partnered with DOE's National Renewable Energy Lab because of our emphasis for solar irradiance. So through the years, we've worked with them, and we've had complementary projects. In fact, we're going to be starting a new one, where we're supporting data over Alaska and things. So we've worked with them, and one way that we've worked with various different partners is to partner with those that provide engineering decision tools for the specific users. So NREL has a number of those like PV Watts and Solar Advisor. We've made our data specially formatted for Solar Advisor. And also within the ASHRAE community, we've worked with the buildings and their very key building modeling system called the Energy Plus system. So we've actually been working with Dr. Drew Crawley from DOE, who actually, he's retired from DOE now, but he still works with Bentley now. But he developed ASHRAE, and they have a energy weather format, Energy Plus weather data format. We provide data in exactly that format so that they can utilize Energy Plus and go to Power and get the data they need, which is hourly. And Energy Plus has become a standard in the building modeling industry as well in terms of that data format. So we get to reach a lot of users by providing data that way. We also we provide data in ASCII format. So Allison's right, we process all the data and provide it in simple formats, but we also support GIS formats for those users as well. So we've really tried to make the data accessible and partner with those that develop decision support tools. One really important decision support tool I'm sorry.
Well, I just want to make sure, I know we have got a packed schedule today, so I want to make sure there's time if other people have questions. As you, Paul and I are happy to answer as many detailed questions as also the general questions now that people may have. I know I saw Megan getting a little antsy about the time.
That's all right, Allison. And Paul, I really appreciate it too, but I do think we need to move on to Norma Jean. I think this is an interesting concept. I think we need to hear a little bit more about it. We should probably digest it a little bit here on the task force. ASCE is very familiar with ASHRAE and some of the other standard setting groups. I think the question that we often are confronted with is we're looking at decisions that are on the 30 to 100 year kind of decision direction. So, it kind of makes us a little bit different than agribusiness or retail or what ASHRAE deals with, right? Because you're not going to design a cooling system for 100 years out. Right. So it's that, how do we translate what you're doing to our needs, I think would be the direction I'd like to see it go. I
just going to make a comment that relates to the work that we've been doing with NASA centers under that CASI project that Allison
right,
mentioned.
and I made a note of that one too.
We are going out 100 years. That was actually going to
be my question there.
Mm-hmm.
All right, so that sounds good. Allison, thank you. Paul, thank you.